This one idea changed the way I think about logic in video games, and if you've never used it, it might just do the same for you. Hi, you probably are familiar with if statements and know how to use them, right? Well, what if I told you there's a smarter way to handle logic that's neither on or off, but anywhere in between? That's what I call scale logic, and it's also today's topic. So let's dive in. Let's begin with what scale logic is. It's a form of logic that lets you determine an outcome based on values that change gradually, instead of flipping instantly like traditional Boolean logic. It replaces Boolean logic when you require not a 0 or a 1, but rather something in the middle. Think about how annoying it is to drop from a height just high enough to instantly kill you, when just a second ago you dropped from an inch lower and survived with plenty of HP to spare. God damn it. That's classic Boolean logic. True or false, live or die, nothing in between. With scale logic, however, you could scale the damage with height or with fall velocity instead, and make it feel way more natural. Some familiar examples of that are jet boots that change the amount of thrust based on your relative velocity, mutators that make your character fatter the higher your KD ratio is, potion making and enchantment systems, and more. What makes these mechanics so special is how they respond fluidly to the player's state, rather than just switching on or off. Let's take an example from one of my favorite games of all time, Unreal Tournament 1999, where there's a mutator that changes your player's physique based on your kills to deaths ratio. The sweet innocent memories of slaughtering bots one after another without ever realizing there's actually a multiplayer option. But I digress. As you can see, instead of flipping instantly from fit to fat, it gradually scales your size, much smarter and cooler than a simple yes or no switch. In contrast to the traditional if statement, which communicates through conditions and true or false statements, the scale logic is communicated through equations that allow multiple results rather than only two. In the Unreal Tournament example, the player's size can be decided in two ways. If we do it in the traditional Boolean way, our code will probably look something like this. Yeah, I know, it's not really a ratio, but you wouldn't want your player to double in size after your first kill just because your kills to deaths ratio is 1 to 0. Anyway, this gives us only three options. Our player size can be either twice the default size if we're good gamers, the default size if we are average, and half the size if we suck. That's a cool addition to the game, but it's very limited and breaks the fluidity when someone sees you double in size in an instant when you kill them. If we choose to apply scale logic, however, we end up with a much nicer and more fluent result, and code, which will probably look something like this instead. Now you might be wondering, where the hell did I pull that equation from? We'll get to that later on in the video. For now, just look how clean and powerful it is. It features 21 states instead of 3, and it's only one line. We still get the same results for a kills to death difference of 10 or -10, but now it's more gradual and fluent. Plus, our code looks far better. If we want to limit the variance, we can even clamp the results between 0.5 and 2. Now, why not just use lots of if statements? Well, sure, you could fake this behavior with like 20 if statements to cover all intermediate steps, but that's very clunky and impractical, especially for floats that will probably require like an infinite amount of loops to account for everything, so you'd better get started. Or not. Please don't. So, we've established that scale logic is superior to Boolean logic in some cases. This is not a video where I tell you to forget everything you know because there's a better way of doing it. No. A good product, whether a game, program, or simulation, uses the best of all worlds. Most of the time, if statements are best. But when you want to spice things up, scale logic can make your work really pop. Let's see a different example. Jetpack. We want the jet to boost our character, but not allow a speed beyond a maximum Vmax. And if the player is falling, the thrust should kick in stronger, enough to quickly stop the fall and start hovering. Here's the Boolean approach to this case. You can see this is very crude. It's rigid and produces abrupt jumps rather than smooth movement. Using the scale logic approach, we can simply write the equation thrust multiply is equal to 1 minus the velocity in the thrust direction over the maximum velocity. This again gives the same solution for some points, but much smoother and with infinite intermediate states in between. In this example, the biggest challenge is similar for both approaches, and that is figuring out what is the velocity in the thrust direction. It's not just speed, it's speed along a vector. Unlike the kills to death ratio, which is very easy to measure, this time the variable is more nuanced and a bit harder to define. So without going into too much science, I'll just tell you that the right way of doing this is by using the dot product between the velocity vector and the thrust direction. I have a whole video on dot products in scale logic applications coming up, so make sure to subscribe so you don't miss it. Okay, so how do we come up with these equations for the scale logic anyway? Well, this is a topic in and of itself, and I plan on making an entire video on the methods that you can apply to reach the right equations for your projects. But the simplest ways I can tell you right off the bat are A. Use a linear fit. That's usually the simplest bet and works like 90% of the time, like in the Jetpack example, but unlike the UT example. And B. Just try to fiddle with some equations and factors to slowly refine your equations until you reach a solution that is at least close enough to what you require. This should help you identify the right equation for you. Why not just use a different solution? You can simplify the entire thing by just setting the velocity to some value when you press the jet button. But that's very abrupt and flow disruptive, and even worse, it might interfere with other effects like wing gusts or break your momentum. Another solution is to maybe use linear damping, which basically reduces your velocity by a fixed amount every frame. That may sound reasonable, but it also introduces more challenges and leaves the issue of the player falling and taking too long to get up. Also, while the equation Unity uses for damping is okay, it's always better to be in full control yourselves and be able to fine-tune things to appeal to your game. In this video, we discuss scale logic as an alternative to Boolean logic for controlling the outcomes of some situations. We showed that it leads to smoother, more natural responses rather than stiff true or false responses. Therefore, it is perfect for cases when you want more realistic and fluid results. Of course, it is not meant to replace if statements entirely, but it's a powerful tool for the right situations. Remember, you don't always have to flip a switch when you can turn a dial. Scale logic is how to make your game feel less like code and more like magic. We also showed that each different feature or mechanic can be approached in many different ways, all of which have their own pros and cons. So in the end, it is up to us, the designers, to know all the different tools and decide which one is best for that application. That's what I try to do, to teach and learn myself as many tools as I can and try to help people create more enjoyable and expressive games. If you want to master this kind of next level game dev skills, make sure to subscribe and catch my next and other videos on dot product, vector maths, and more, all tailored for game developers. Thanks for watching this video. If you liked it, please consider dropping a like, and if you found it interesting, please leave a comment and share it with some of your friends. That's all for today, and I'll see you in the next one. Cheers, guys!